All right, to start with our definitions, we have the user. The user is someone who will pay the bills in the household. The household is what controls everything. It brings everyone together and divides the bills together. The profile is the profile. The questionnaire is how we know which bills to give the users and how much they will cost. All right, we have main two components. The client is our web application that communicates with the database, and then the database, which will store all of our users' information. How much, all of their bills, how much they cost, and all of that.
So what we have is the requirements. As you can see, is the first one we have the login requirement. As you can see, there is no dependency, and all it is a user prompted to sign up a page. We're able to submit login information such as username, email, phone, passcode, and also get login in through with the Google API. And user data will be stored to the database. We can then see is a questionnaire, which is the next page, which is fully dependent on the first page. Here, pretty much the user will load their information, so it's easier for them to load to the database as well as be displayed onto the actual homepage. The next is actually the homepage. That is fully dependent on the two previous, the homepage or the questionnaire as well as the login page. The main page displays the bills, expenses, household members, Google Calendar, and transaction log. The next is a profile page, which is dependent on this previous page up here. This pretty much displays the email, phone, house, as well as the name. This is fully gets dragged off from the database. Next is set reminders. This is dependent off of a future or UI requirement 8, which is down here. This one is pretty much where the household manager can use this function to remind people, the roommates, to pay their portions of the bill. Next is the bills expenses management. This is fully dependent off the homepage. This is where the household manager can adjust the amount of 4% of the household members are paying. Next is the make request payment. This is also dependent off of the household or the homepage. This is pretty much exactly like the bill expenses, but pretty much what you can do is check the ones that you can you want to pay, and then you click pay, and then it will go straight to PayPal. And then lastly is the household management system. This is where the page is only accessible by household manager to edit, remove household members, a page for household members to view details, or remove household members. And that one is also dependent off of the homepage.
Now, after our UI requirements, we'll go into the functional requirements. So our first functional requirement is going to be the core of this web application, which is going to be the household database, or one of the two cores. Household database is where the questionnaire stores the information, such as house size, type, the bills, the amount, due date, all that data is going to be stored here. And the household database is going to rely on the Firebase server, which mentioned earlier is the actual database that we are using to store and pull the information from, and is going to also require the questionnaires inputs, obviously, to be able to store it in there. Our second functional requirement is going to be the user database. This is where the user information such as email, phone number, the household ID that they're going to be creating, as well as their user ID, is going to be stored. Again, depending on the Firebase server, to be stored there, and relying on the questionnaire to pull that information and store it there. And then the next is going to be the user profile, which will give the user access to the database that contains the information, and it will be displayed there on the screen, kind of like the wireframes that were showed up above.
For the user sign up through Google API, it allows the user to create a profile through Google accounts and gives me access to the user's Google Calendar. We authenticate our application users using the Google sign-in. We figured this was the best way at this point to give our users access to our services, because our reminders will be dependent on Google Calendar API. So we need to make sure that they had an account. This has a dependency on info9, which is a sign-up page. The Firestore saves user IDs, which are connected to their Gmails, which is saved in our Firestore authentication.
The next functional requirement being the questionnaire. The questionnaire will be the, like stated previously, the initial user input of all their data for the user database and household database. And that also relies or has a dependency on FR9 because you need to sign up before being redirected to the questionnaire. Then there will be the bill functional requirement. This is actually a sub-collection inside of the Firestore database of each individual household, and it will be capable of containing the amount, due date, and the percents that was again stated previously. This function will also be able to split each of the bill amongst all the roommates in there.
So for Google Calendar, so on the right column in the homepage, there will be a Google Calendar render link. So once user click that icon, it will direct them to their own Google Calendar, and then they can add or remove any bills or reminder they want to set for themselves in the Google Calendar. So that's how it links to their account. So for the PayPal API, same as the Google Calendar, on the right column of the homepage, there will be a link direct user to the PayPal page, so they can set up their PayPal account or even log in to the PayPal account and make payment or request payment from people in the household to ask them to pay off their bills.
And then for our last functional requirement, this hasn't been implemented yet, but as well as with the salt hashing for passwords and usernames, eventually there will be a separate page for signing up with a Roomie specific account instead of a Google account, and that is down the line.
For non-functional requirement 3, network database connectivity, we created a pipeline route that connects the UI, our front-end HTML, to our database in Firestore by using Node.js and calling scripts from the front end and running the scripts and having it connect to the backend and retrieve information and display it. For our Firebase data model, it shows 2 of our databases that we use in Firestore, our user database, which houses user IDs and as documents. And each user ID has an email, house ID, phone number, user ID again, and a username stored for each user. This is connected to our house database by the house ID that is stored in the user ID document. So this is used for querying because it is a hierarchical and a tree structure. Each collection has a house document. Each house has the house name, house size, type, ID, number. It has a sub collection of bills because each house will have different bills, and a array of roomies, which is going to be the list of all the people that reside in that household.
All right, so now we're going to go over the projects tab for our workflow. As you can see, we have 31 done. Me and Farah are mostly in charge of the front end stuff, and then Abdul, Molly, and Alvin are in charge of the back end. So as you can see, here they are. So profile page, wireframe, create prototypes. So this is pretty much ranging from the beginning of the semester all the way till now. As you can see, there's a lot done. Nothing's in progress because pretty much everything that we wanted to finish is done. Here are some of the issues that we marked as well. And that's linked to our issues tab, what we will talk about later. And then these are our to-dos. These are mostly motivated for next semester.
So the issues tab we mostly used for some of the lab assignments that we had for the checkups and updating the actual wiki during the documentation phases. We also had a couple when it came to some of the more bigger projects that we started delving into, but ended up doing just a very basic version of for now, like the Google login and the Google Calendar and such. So this is the household database script that we run in the questionnaire. So these are some variables that we use to take the inputs from the fields of the HTML and calculate some math for actually checking to see if these values are valid when it comes to actually being checked. After that, it'll call the new house function. And in the new house function, it'll create and assign the document to their corresponding values. And after that, it'll call the make bills function, which will actually call the make bills, which will make the sub collection of bills and assign that sub collection with the bills as documents with their corresponding amounts and bill percentages.
Okay. But if the user is joining a house, we have a second event listener for a different button. It calls the find house function. The find house function, it queries for the household name, and then it assigns that to a document, and then the user gets added through these functions. And then the rest of the household script has just the setters and then a getter for now. Okay. All right.
Next is the questionnaire HTML page, which is pretty much the interface for the questionnaire. What we use is Bootstrap, which makes it super easy for us to actually formulate the page, make it super nice and organized. As you guys seen in the demo, it gets separated by two parts when you want to join the household, as well as when you want to create a household, and that's fully controlled by this little script right here. So as you can see on the third part, you put join or create household, that gives an ID, and that ID is passed, and then depending on that ID, it goes in this little statement. If it's created, then it takes this little route where you have to pretty much create your own household. And if not, it goes all the way down to this one where you pretty much put the name of the household, which we can see we were able to actually put the name of the household, grab it from the database, as well as add the new member into the database. And that's pretty much it. We have a couple scripts down here that will be talked about, as well as some of the links up here as well, such as Bootstrap and other database modules.
So this is the HTML file for our homepage. So basically, it starts by importing bunch of JavaScript file. This is to get the information from database to portray the information on our homepage. So basically, our homepage is separated by navbar and a left column, middle column, and right column. So on the navbar is basically just display the dashboard, household, and my profile here. And for the left column, it actually display the user photo and the user email address and username. And the middle column, it display the bill informations. So it display the bill's name and the amounts here. And moving on to the right column, it display the Google Calendar. So it will direct the user to their own calendar, and also the PayPal link for them to log in into PayPal and pay their roommates. And for the footer, it just direct us to the GitHub page, to our team GitHub page. And down here is just a bunch of script file for me to work on the pop-ups for the pay bill.
I standardized the way that we initialize our Rooney app. So in order to do this, first we need to get information for the configuration of the app. And after we put in an app JavaScript file, we initialized it and exported the app. And this gives other JavaScript files access to the database. For instance, another JavaScript file can import this app from in an app and make an instance of it, which allows it to have access to the database in order to do queries, lookups, and any kind of writes, any kind of interaction with the database in our first store.
This is our pull request tab. This just shows how many pull requests we've done in the length of our project so far. And yeah.
This is the end of our presentation for our app, Roomy. Thank you for your time.
Boom.